So hi everyone, today we'll be talking about a very popular scaling method for numerical features called as min-max scaler. So basically a min-max scaler follows the formula x minus the minimum of the total numerical feature upon maximum of the numerical feature minus minimum of the numerical feature. So here is the formula written. So basically min-max scaler, as you would have guessed, is sensitive to outliers because it is using the minimum and maximum values of the numerical feature, and eventually mostly these are outliers in a real world data set. Also, another point to note about min-max scaler is that it scales a value from a range of 0 to 1, and it works pretty well with uniform data distributions. So basically one of the methods to curb this outlier problem is that instead of choosing the minimum and maximum value of the numerical feature, we choose out onto some lower and upper bound. Now this can be any value, like the 90th percentile, the 10th percentile, etc. Following the above formula, we again scale up the values using the same formula, but instead of using min and max values, we are using the lower and upper bound that we have set, and these values shouldn't be minimum and maximum. Now any value that has a value going beyond 0 and 1 should be clipped to 0 and 1. This is called as clipping. So now we will look into a general method of how the general implementation of WinMax scaler. So we have created a dummy data frame here where we have got three columns A, B, and C. Where we have introduced an artificial outlier in the variable A, so that we can see how min-max scaler performs for a given if the dataset has an outlier in it. So using the scalar package, we have imported min-max scaler. We have called fit transform over the data frame. Now scale underscore df that is written by the fit transform is a numpy array. So eventually we are using the pandas data frame to convert that numpy array into data frame, and eventually are plotting the distribution after scaling. So you can see that how in the first distribution, that is for variable a, the values are getting skimmed because of the presence of an outlier into a very very small range, that is 0.05, something around that, to 0, instead of distributing between 0 to 1.